everyone. I will be looking at logarithms and just doing a short lecture on this topic. Now, logarithmic function is the inverse of exponential. Now, before I go in detail with this, just to note that the common logarithm is log and the base is 10, but you're not seeing the base. So if you look on your calculator now, you will see log and there is no base. It looks like there is no base, but the base is 10. ln is called natural log and it's right beside the log on your calculator. This is a part of the log function and the base is e, so it's log base e. Now remember I say the logarithmic function is the inverse of exponential. So we can convert from log form to exponential or vice versa. So this is our base and all log has a base. So if I'm gonna write it in the exponential form, then what we do, we go ahead. This is the base. So I have my base is 3. The p becomes the power and it's going to be equal to the number that's 9. So that's how we change it from log to exponential. The same scenario here. A is the base. So I have my base is a. 9 is the power and it's equal to 6. Now I want you to do this one and share in the comment section what's the answer for this in exponential form. Now we can move in the reverse. So if I have 4 to the 3 equals 64, I can change it into log form. First you write log. And then what's the base? The base is 4. What's the power? The power is 3, so it goes over the equal sign. And then you have the 64 here. Same scenario here. What's the base? The base is 2. And then the 32 will go beside the log and the power goes over the equal sign. So for this one, I want you to go ahead and do this question, write it in the log form, and put it in the chat. What's your answer? Now I'm going to look at an activity where we are going to write it in exponential form and log form. So let's look at that activity. Express each exponential or index form, that's another way to call it, in logarithmic form and each logarithmic form in index form. So we have 2 to the 4th equal 16. Given that this is in exponential form, if I want to write it in log form, I will have log. And what's my base? My base is 2. I have 16 goes beside this, and then I have 4 over the equal sign. If I have 3 over 2 raised to the negative 2 equal 4 over 9, even though the 3 over 2 is a fraction, it's still the base. So you write log first, and my base is 3 over 2. And then the 4 over 9, that's over the equal sign, goes beside the log. And then it's equal to negative 2. So for this one, again, I want you to write the answer in the chat. Write these two in log form for me in the chat. If I have log base 2, 64 equals 6. Writing it in exponential form, I'm going to have 2 is the base, 6 is the power, equal 64. Let's look at ln 1 equals 0. Now, something we need to know is that ln is the same thing as log base e. So this is saying log base e 1 equals 0, and then writing it exponential form, this is e to the 0 equal 1. Next we have, let's look at the log x equal 4. This has a base. The base on this is 10. So writing it in exponential form, I'm going to have 10 is the base, 4 is the power, and it's equal to x. Now the one that I didn't do, I want you to write the answer in the chat. What is the exponential form for this? Let's continue with the rules. Now this is the change of base formula, where we can change to any base we desire. But given the questions that we'll be doing in class, we are going to evaluate something like this. So for example, if I have log base 425 and we ask you to evaluate this, we would use this change of base formula where we have log in the numerator, log in the denominator, which is base 10, and then m goes in the numerator and b goes in the denominator. So if I have log base 425, to evaluate this, I will have to put in our calculator log 25 over log 4. And then calculating this, you need your calculator for this. So you put log 25 divided by log 4 in your calculator. And I'm going to round it up to 2 decimal places. So I'm going to have 2.32. But if we had said 3 decimal places, then it would be 2.322. So if I have another question, say for example, I ask you to evaluate log base 37, then we will say log 7 divided by log 3. And then once again, we'll put this in our calculator. So we'll have log 7 divided by log 3. And my answer will be 1.77. Now, there are other properties that we need to learn, and some persons will say rule. For example, we need to note that log 1 is 0. So it doesn't matter what's the base. I could have the base being 5. Log 1 is always going to be 0. So it really doesn't matter what's our base. Log 1 is always 0. This is when the base and the argument is the same, then the value is 1. So if I have log 3, then my answer is 1. Log 5, then my answer is 1. So once they're the same, the answer is 1. When you have a power, we can carry it in front, or vice versa. We could have carried the power upwards. So let's look at an activity. Suppose I have log base 5, 25. And I ask you to evaluate this. So you would change 25 to 5 square. And they would carry the power in front. So you'd have 2 log 5. And we just learned that log 5 is 1. So this will disappear. So I'd have 2 times 1 to give me 2. The next rule is saying when you multiply, you add, or you can say when you add, you multiply. So if I have, for example, log 3 plus log 5, then my answer would be log 3 times 5, which would be 15. If I have log 2, so the base is 5, plus log base log base 5x, Then I'll write the log ones, and then my base is 5, and 2 times x give me 2x. The next rule says when you minus, you divide, or when you divide, you subtract. So in other words, once you see subtraction, then it means I'm going to write it as division. So I could have log 10 minus log x. Then I'll write it the log ones with the base. And then this would be 10 over x. So once you see subtraction, you are going to write it as division. So let's look at these activities that we have here. I'm going to do some of them, and then you can complete the rest in your tutorial class. Just to give you an idea of how to approach log questions. So if I have log 30 plus log 40 minus log 15, let's look at that one. So if I have log 30 plus log 40 minus log 15, one way is just to say, okay, when you add, you multiply, so you'd have log, and you multiply 30 times 40. So you'd have 30 times 40 minus log 15. So we know 3 4 is 12, and we have 2 zeros, so that means we'd have 1,200 here when you multiply 30 times 40 minus log 15. And then we know when we subtract, we divide, so you write the log ones, and then you have 1,200 divided by 15. Now, if it can be reduced, then it is expected for you to reduce it. So don't leave it as this. If you know, we can go ahead and reduce. That's the expectation. So 15 into 1,200 goes 80 times, so your answer would be log 80. Now another way that we could do it is just write the log ones, and we say positive goes in the numerator, so you have 30 times 40, and the one that is minus, divide, so it goes in the denominator. And then you simplify. 30 times 40 is 1,200, so you'd have log 1,200 divided by 15, and we will still get the log 80. Next one we have is log x minus log 2 minus log 50. Sorry, minus log 5. So you could write log ones. And since the log x is positive, that means that you're going to have x in the numerator, and then the 2 and the 5 would be in the denominator, but you'd have 2 times 5. So that means we have log x over 10. And that's it. Now, the next one we have the one that says 3 plus log x. Sorry, we have the one that says 3 plus log 3. We need to write it as a single log. And right now, the 3 is not looking like a log, but we can make it to be log. We can rewrite 3 as 3 times 1. Remember the rule that says log AA is 1. Now, because this log 3, we have the base to be 10. That's the giveaway to say we need to change the 1 to log 1010, because we know log 1010 is 1. And if you look at this will disappear, so I still have the number 3. Then we have log base 10, 3, if you want to continue in that trend. Now you would carry this up, so you'd have log 10 cube plus log 3. Now 10 cube is 1000, so you'd have log 1000 plus log 3. And we know when we add, we multiply. So you'd write the log once, and then multiply 1000 times 3, so that gives us 3000. So our answer here is log 3000. Now the next one we have is 1 plus ln 7. Now for this, because I have ln here, and we know ln e is 1. If you're not sure why is ln e is 1, remember ln is the same thing as log base e. So we know that when these are the same based on the rule, then the value of this is 1. So I'm going to change 1 to ln e only because I have ln on the other side. So I have ln e plus ln 7, and then you write the ln once and multiply e times 7. E times 7 is 7e. Another one that we have here, we can do the 2 plus log base 5 8 minus log base 5 10. The 2 again you have to change. And remember what I said, when we're changing it, we have to rewrite 2 as 2 times 1. And the 1 now, because we have 5 here, we're going to change the 1 to log 5 5. Because log 5 5 is 1, so 1 times 2 still give me the 2. Then I have plus log 5 8 minus log 5 10. Carry this up, so it becomes a power, so I have log 5 square plus log 5 8 minus log 5 10. 5 square is 25, so I'd have log base 5 25 plus log base 5 8 minus log base 5 10. Then we go ahead and write it as 1 log. So I'm going to write log base 5, and then in the numerator, these are two positives, so I'm going to have 25 times 8. And then in the denominator, I'm going to have the 10 because of the minus log. Now let's simplify. So I have log base 5. We know that 25 times 8 is 200. So I have 200 over 10. And then this cancel. So I have log base 5, 20. And that's it. Now for the next one we have 2 log AB minus 2 log A plus 1. So I'm going to first carry out these, which are the power. So I have this as log AB all square minus log A square. And we have a 1. So we're going to change it to, if you say log 10, that's correct, or log 10, 10. Reason why we do that, because the base is 10, it gives you the idea that it gives you the hint that we need to change it to 10, 10. So in other words, the base on these is 10. Now this part is the same thing as saying log a square b square minus log a square plus log 10. And just as how I mentioned, you are going to write log once. And in the numerator, you have a square b square times 10 all over the a square that's in the denominator. So positive numerator, negative denominator. These cancel. So that means we have log b squared times 10, which is the same thing as saying 10b squared. Now, the next one I'm going to leave for you to do. I'm going to do the other one here. So, we have ln x minus 2 ln 4. Carry this up, so it becomes the power. So you have ln x minus ln 4 square, which is 16. So you have ln x minus ln 16. Write the ln ones. Then you have x in the numerator, 16 in the denominator, and that's it. So these two you can do on your own. We're going to continue the activity. So this activity is asking us to expand the following, right, as a sum difference. And if there's a constant, then we will write the constant, if there is one. So the first one we have is log base 2 4x cubed y to the 90 over z 10. So first we're going to expand it. So I'm going to have log base 2 4 plus log base 2 x cubed plus log base 2 y to the 90 minus log base 2, this is the letter z, 10. Now if you realize I have these three being addition because this is saying 4 times x cubed times y to the 90. So they're being multiplied, so you write it as addition. Now 4 is the same thing as saying 2 to the 2. So I'm just going to carry this power in front. So I have 2 log 2, 2. So 4 is 2 to the 2, and the power can be brought in front. And then we can also carry these in front. So that means I have plus 3 log base 2x plus 90 log base 2y minus 10 log base 2z. Now log 2, 2 is 1, so this is going to disappear. So that means my answer here will be 2 plus 3 log base 2x plus 90 log base 2 y, and because it can't hold, I'm going to write plus, sorry, I'm going to write minus 10 log base 2z. So this is one. If you look at another one, say the ln one, where I have ln 100 e to the 10 over e to the 2x x to the 10. So expanding this, we'll have ln 100 plus ln e to the 10 minus ln e to the 2x minus ln x to the 10. Now, this is a power I can carry in front. This is a power I can carry in front. This is a power we can carry in front. With ln 100, it's optional if you want to change the 100 to 10 square and then carry the 2 in front. So you'd have 2 ln 10, that's optional, plus 10 ln e minus 2x ln e minus ln 10 ln x. Remember, we learned that ln e is 1, so this is gone. So you have 2 ln 10, or some persons would have ln 100. It depends on if you have an MCQ and what it has. Plus 10 minus 2x minus 10 ln x. The next one that we have here, I'm going to do ln 10e over x plus 5 to the 6. So the 10e is being multiplied, so that's why I'll have this as ln 10 plus ln e minus, this is not being multiplied and it raised to a power. So I'll just have this as ln x plus 5, because there's no rule for me to split the x plus 5. So we're going to leave it as it is, raised to the power 6. Then I would carry the 6 in front, and then we know ln e is 1. So we can leave the ln 10 as it is. Then we have plus 1 minus 6 ln x plus 5, and that is it. We have nothing else to be done. Now, if we have 2 log 256 over 3 log 32, we could simplify this by changing 256 in index form. So now we need to know, what can we change 256 to? 256 is the same thing as 2 to the 8. So I'll have this as 2 log 2 to the 8. And then 32 is 2 to the 5. So I can have this as 2 to the 5. So I'll carry this in front along with the 5 in front. So I'll multiply 8 times 2, that's 16 log 2 over 5 times 3, 15 log 2. And then we'd cancel this, so I'll have this as 16 over 15. Now, for these two that I haven't done, I want you to go ahead and do it. Remember, if the 16 can be broken down into index form, you do so and carry the power in front and get the constant. We have 2 items in the denominator. So we can use the previous activities to assist us in doing E and F. Now, the last thing that we're going to look at is how to solve equations using logs. So we have 4 to the 3x equal 149. What we're going to do, because we cannot change the 149 to base 4, or we can't get them to be the same base, we can do one of two things. The first step is to rewrite it into log form, where log is the base. Sorry, you rewrite it into log form. So the base is 4. The 149 goes beside the log, and then it's equal to 3x. Remember, we did this activity here when we write this in log form. So we'll have, this is the base, the 16 goes beside the log, and then we have the 4. So it's the same thing that happened here, where we write it in log form. And then if your calculator cannot read this, we have to use change of base to write this as log 149 in the numerator, and then log 4 in the denominator equal 3x. Then you take your calculator and enter log 149 divided by log 4, and you round it off properly. So I'm going to say 3.6 using one decimal place equal 3x. And the last thing is to divide both sides by 3. So when I divide both sides by 3, you get x to be 1.2. So my x value is equal to 1.2. So that's one method. The next method, we can log both sides. So I have 4 to the 3x equal 149. We log both sides. So you're going to have log 4 to the 3x equal log 149. And then you carry the power in front. Remember, powers can go in front. So you have 3x log 4 equal log 149. Then you divide both sides by log 4. So this cancels. So you have 3x equal, you put log 149 over log 4, which is the same thing as the left-hand side. You get 3.6. And you divide both sides by 3. And we get the same answer, x equal 1.2. So we have 5 to the 4x minus 3 equal 199. We are going to log both sides. That's one method, by the way. We log both sides. And then you carry the power in front. So you have 4x minus 3 that you carry in front, and then you have log 5 equal log 199. Then you divide both sides by log 5. So this cancels, so you have 4x minus 3. And then the log 199 divided by log 5, you have to put that in your calculator. So I'm hoping you have your calculator with you here. Not pause the video and go for your calculator. And I'm rounding off to one decimal place. So I have 3.3. Now we have to carry this over. So that means I have 4x equal 3.3 plus 3. So 4x equals 6.3, and then you divide by 4. So that cancels. And then we enter 6.3 divided by 4. And our answer is 1.6 or 1.575 if you want to put that. Now remember I said there are two ways to do questions like these. So I could have done writing this in log form. So writing it in log form, so the base is 5. Then I have 199 here equal 4x take away 3. Then I go ahead, use change of base formula, so I have log 199 divided by log 5 equal 4x minus 3. And if you look back on my slide, the previous slide, you'll see we have the same thing here. Log 199 divided by log 5, that gives us 3.3. So it'd have 3.3 equal 4x minus 3. And then carrying over the 3 to give plus. So 3.3 plus 3 equal 4x. So that means 4x equals 6.3. And then we do as before, divided by 4. So that means x equal 1.575, or we can say 1.6. Now, if we have 3, well, it is 1018 equal 3e to the 2x. But I'm going to write as 3e to the 2x equal 1018. It's the same thing. First thing, we divide both sides by 3. So we have e to the 2x. And I'm just going to go ahead and divide 1018 by 3. And roll it off to 339.3. Because I have e, I'm going to ln both sides. You can write it in the exponential form in log form, but I'm just going to ln both sides. So I have ln on the left, ln on the right. Then I carry this in front, so I have 2x ln e equal ln 339.3. ln e is 1, so I have 2x equal ln 339.3, and then divide both sides by 2. This cancel, and now you can put this in your calculator. So select ln 339.3, then you divide it by 2, and you get 2.9, or if you want to say 2.913, if you want to use 3 decimal place. Now, don't worry if you're seeing a log question. For example, if we have log 5x equal 3, the base is 10. So you'd write it in exponential form instead of, the previous one, we would put it in log form or introduce log. We write it in exponential form, so I'd have 10 to the power 3 equal 5x. And 10 cubed, we know it's 1000. So we'd have 1000 equal 5x. And divide both sides by 5. So this cancels, so x is equal to 200. Now, there's one that I didn't look at, and let me just explain, because we have done quite a few questions. This one looks different, but it's similar to the other exponential. The only difference is that the first thing you have to do is care about it's the 3. So the first thing that you have to do, so the first thing you have to do is care about the 3. So you have 4 to the 2x minus 9 equal 755 plus 3. So you have 4 to the 2x minus 9 equal 758, and then we're used to what we had before, where you either log both sides or change the exponential form to log form. The one where we have log base 2, 2x plus 1 equal 3, we are going to write this in exponential form. So this is 2 to the 3 equal 2x plus 1. 2 to the 3 is 8, so I have 8 is equal to 2x plus 1. Then I care about the 1, so I have 8 minus 1 equal 2x. So that's 7 equal 2x. And we divide by 2 on both sides. So that means x is equal to 7 over 2. Now the next one that we have here, if you have 2 logs, so we have log x plus log 5 equal 2. Get it as 1 log first. So when you add, you multiply. So you write the log ones. And x times 5 is the same thing as saying 5x. So you add, you multiply. The base is 10. So write it in exponential form. So I have 5x equal 10 is the base and 2 is the power. So 10 squared is 100. So I have 5x equal 100. And then divide by 5. So that means x is equal to 20. Well, this question has subtraction. So if we're supposed to do this one, let me just go ahead. What we would do, so we're doing this question, we would write the log ones, and because it's subtraction, it's going to be division. So you'd have x over 4 equal 1. And then exponential form, 16 is the base. 1 becomes a power equal x over 4. 16 to the 1 is 60. So I have 16 equal x over 4. And because I want to get rid of the 4, and it's in the denominator, I have to multiply both sides by 4. So we have to multiply both sides by 4. So this cancel. So x is equal to 16 times 4 to give me 64. So only because the 4 in the denominator, we had to multiply both sides by 4. Alright, so that's it. Any question, you can leave a comment or you can contact me by email for those